Okay, the law of cosines. In this video, we're going to look at what is it, and we're going to look at how to prove it. This is not a video focused on how to solve it. I'm planning on making one of those soon. I could probably link it here once that's done. Okay, so what is the law of cosines? Well, it's based on any triangle. So let's draw a triangle that represents any triangle. Here's a triangle. It does not have to be a right triangle or anything special about it. Let's label our corners, our vertices, A, B, and C, using capital letters. And then let's name the side lengths, where we're going to do a lowercase a on the opposite side from the capital A, lowercase b on the opposite side from the capital B, and a lowercase c on the opposite side from capital C. So that's how we've named it, and we've kept track of which sides are opposite which angles, conveniently using those letters. All right, now what does the law of cosines actually say? So the law of cosines says that if you do side length c squared, so that's a lowercase c, hard to tell, I know, equals the a squared plus b squared, and if I stopped right here, that's the Pythagorean theorem, and that's how I memorize this. It's the Pythagorean theorem minus some stuff. What is the stuff? It's 2 times a times b times the cosine of angle C. So if you just memorize the Pythagorean theorem minus, and then you memorize 2ab cosine c. Notice you have that nice ABC in there. It's ab cosine c with a 2 in front. This is not too hard to memorize. So Pythagorean theorem minus 2ab cosine c. All right, but well, also, by the way, you could do this for any of the letters because a, b, and c were not special. So the main thing you should keep track of is that the cosine c, there's only one cosine in this formula, and it's going to match up with the letter here. So these are opposites, okay? Remember how we labeled this. So what this really says is that, like you could put an A here instead of the C, what matters here is that the cosine angle is the same as the one that's by itself on the other side of the equation. Those are opposite side and angle pairs. That's what this formula is saying. So you could write it down mixing up the letters as long as those two match as the opposite paired up sides. Okay, but now let's get into an actual proof of this, meaning why is this true? How do we know this is true? Well, I like to talk through proofs as I would actually think them out as I was trying to come up with them. And to be honest, I don't memorize all the steps of a proof. I'm going to kind of come up with it again because I have a logical framework for this. Number one is, notice that it looks a lot like the Pythagorean theorem. So if I was going to do this proof, I would start out by writing down stuff using the Pythagorean theorem. Now, the Pythagorean theorem only works on right triangles. So that's actually another way to think of the law of cosines. It's basically the Pythagorean theorem with an adjustment at the end, that minus 2ab cosine c thing, to make it work on any triangle. That's another way you could kind of think about it. Now, we're going to need a right triangle, so how about we draw what I would consider a height line, like if I was going to calculate the height, like the area, I would need the base times the height divided by 2, right? Something like that. So I'm going to call that h. We could have called it whatever we wanted. I'm just calling it h. Okay, now if we're going to do these two right triangles we have now, notice we've now split this into two right triangles. I'm going to name this point D. We probably won't need that, but I like to name points when I draw them. Well, okay, so we should probably split this up. I'm going to call the distance from here to here, right, from C to D, I'm going to call that distance x. And remember, that's different than the distance B, which covered all the way from C to A. Then we also should name the distance from D to A, but instead of introducing more variables than we need to, can't we use the B and the x? Pause the video here. How could you name the distance from D to A using the variables B and x? All right, did you think of calling it B minus x? Because that is the difference of b, take away the distance of x, and you are left with b minus x, and now x plus the b minus x would combine to the full length of b. All right, so that should work out for us. Now let's write down the Pythagorean theorem using the left-hand triangle. Okay, well, the Pythagorean theorem, which I have a video about, I can probably link up here or something, is just that the leg squared, so x squared, plus the other leg squared, that would be the h squared, equals the hypotenuse squared, which would be the a squared. And that's the Pythagorean theorem on the left-hand triangle. Now let's do it on the right-hand triangle. The right-hand triangle would be one of the legs squared, which could be h squared, plus the other leg squared, which could be b minus x squared, and then that would equal the hypotenuse squared, which is c squared on that one. Okay, so we've written down the Pythagorean theorem twice, What can we do with this? Is this useful at all? Well, again, we did it because this formula looked like it had the Pythagorean theorem in it, right? So we got that. Now what I would do is look at, is there a way we can combine these two things together? Do they have something in common? Well, one thing you might notice is there's an h squared here and there's an h squared here. We can use that to combine this formula together and to simplify it. Let's solve each of these for h squared, meaning get h squared by itself. Well, if you look at the one on the left here, if you just subtract an x squared from both sides, that would leave you with h squared equals a squared minus x squared. And on the right-hand side, let's do the same thing. I want to get h squared by itself, so subtract b minus x squared from both sides. That would leave you with h squared is equal to the c squared minus b minus x squared. Okay, so what do we do with this? Well, both of them were equal to h squared, right? We have the h squared here, and we have the h squared here. Notice that the h squared on the left is equal to this, a squared minus x squared, and the h squared on the right is equal to c squared minus b minus x squared. That means that these two things are equal to each other because they're both equal to h squared. You could also just think of that as substitution, substituting something into one side that is equal to h squared. There's lots of ways of thinking about that, but the point is we can now combine these two formulas as a squared minus x squared equals c squared minus b minus x squared. Okay, so we've made some progress. And what we want to do is see if we can simplify things at all. Well, I'm noticing that the actual formula in the law of cosines doesn't have any x's in it, so we probably want to get rid of that. By the way, we've already gotten rid of the h's that the original formula didn't have, so we're making progress. So that's kind of how I'm guiding my thought on this proof. I want to get rid of these x squareds because they're not in the actual formula. So one thing I'm thinking is I might be able to get rid of it if I expanded this b minus x squared. Let's expand that. B minus x squared means b minus x times b minus x. And that should end up as b squared minus 2 copies of x times b, plus x squared. That's just doing, some people learn that as FOIL, first, outer, inner, last, whatever. It's the b times the b times the negative x times the b, and the negative x times the negative x, and it's that all added together, okay? So that's what we end up with here. Now, we've got the c squared minus that on both of these steps, and it's minus that quantity. So how would we simplify that? Well, we're going to have c squared, and then we'd have minus b squared plus 2xb minus x squared. Okay, and the left-hand side of our equation is still a squared minus x squared. Wow, are we getting anywhere? It almost looks worse. Well, do you notice that we have a negative x squared on both sides? We have a negative x squared on both sides. So could we just add x squared to both sides? If we did that, it would go away. And that would leave us with a squared equals c squared minus b squared plus 2xb. Are you good with that step? We added an x squared to both sides. That got rid of it off of each side, right? Okay, so notice that our formula is looking pretty good now. It just has one x in it in one spot, and our original law of cosines formula doesn't. But our law of cosines formula does have like a 2ab cosine c, and we now have a 2xb. Those seem related. Could we turn that x into that cosine? We know that somehow we need to get this cosine in here, right? So how about now that we're simplifying things a bit, now we figure out how do we get cosine involved in this? And does it have anything to do with the x? Could we maybe do a substitution? That's my thought process. So let's jump back into the triangle and look at this capital letter C. Let's write down the cosine of that angle. Well, that would be cosine of C, and remember cosine is the ratio of the adjacent to the hypotenuse. In this, the adjacent side would be x, and the hypotenuse would be a. So the cosine of angle C is related to x. Let's actually solve that for x. Let's figure out how x equals something related to cosine C. To do that, you would multiply both sides of this by a, right? And that's now going to leave us with x being equal to a times cosine C. Okay, so x is now equal to a times cosine C. So, hey, can't we use that? X is equal to a times cosine c, which means that anywhere there is an x, hey, we've got one over here, right? I just highlighted it in yellow back in our formula. Anywhere there's an x, we can replace that. We can substitute that with something that's equal to x, which is a times cosine c. Let's see if that gets us anywhere. So a squared equals c squared minus b squared plus 2a cosine c times b. That's what we get when we substitute that in. I'll highlight the piece that we substituted in for the x so that that is clear, right? That's what we did there. All right, we're almost done, guys. Doesn't this look almost like our law of cosines formula? We just need to rearrange things. We want to get that c squared by itself, right? We want to get that c squared by itself. How could we do that? Well, could we, let me zoom out and scroll up a little bit so we got some more space. Okay, so how could we do that? Well, I'm thinking that what I'd like to do is get rid of some stuff we don't actually need here. Let's get that c squared by itself. So what I'm getting at here is if we look at the law of cosines formula, the c squared is by itself. So how about we get this c squared by itself right here by adding a b squared to both sides and by subtracting a 2ac cosine cb. Actually, you know what? Let's make this look a little bit nicer. That'll actually be our next step. Let's make some things match up. This 2ab cosine c. Are we good with that? We can rearrange the order of multiplication, right? That's all I did here. I just rearranged the order of multiplication. Why did I do that? I wanted it to match that stuff at the end of our formula, okay? So we good with that? I rearranged that a little bit. I'm also saying that we should subtract this from both sides, okay? And I also want to add a b squared to both sides. What I'm trying to do here is get rid of all of this stuff so that my c squared is by itself. But that means we've got to do it to both sides. We're going to add a b squared and subtract a 2ab cosine c from this side. Now, what does that actually leave us with? On the right-hand side, we would just have c squared. And that is now equal to a squared plus b squared minus 2ab cosine c. We did it, guys. That's our formula. I mean, the left and the right are reversed, but equal sign, that's fine, right? Flip them. We did it. That's the proof of the law of cosines. I'll do a future video where I do examples of how to use it. Thank you and have an excellent day. Feel free to leave questions in the comments section. And you could like and subscribe to the channel and all that if you're interested in math help.